Hey everyone, thanks for tuning in. Today we'll be looking at how to solve trig equations. So this is quite a large part of trigonometry, and a lot of students in fact do find this a bit difficult. So this will be a three-part series. So this lesson I'll be taking you through four simple and elementary examples. The next lesson we'll be looking at how to change the domain for these types of questions. And the third and final lesson we'll be looking at some harder examples. So for this lesson, we got four questions lined up, and I'll just be taking you through them and just showing you the basic process of how to solve these trig equations. So let's begin. All right. So the first question we have is that we need to solve cos x equals root 3 on 2 for the domain from 0 to 360 degrees. All right. So the first thing that we need to do is find our reference angle. Okay. And our reference angle is going to be equal to x being the inverse cos of root 3 on 2. Okay? And that's going to give us 30 degrees. So this is what we call our reference angle, and we put in brackets here that it is indeed our reference angle. Okay? So this reference angle, if you are unsure on what the reference angle means, I highly suggest you take a look at the ASTC video that I made previously. And the purpose of the reference angle is so that we can actually relate an angle in each of the four quadrants towards this. And what I mean by this is we first got to observe that cos x is greater than 0 because it's positive root 3 on 2. And where is cos x greater than 0? So where is it positive? So we make a statement, but cos x is greater than 0 in the first quadrant, in the first and fourth quadrant, okay? So therefore, x is equal to 30 degrees, or like theta, because that's how we define angles in the first quadrant in terms of a reference angle. And in the sorry, that was the first. And in the fourth quadrant, we define it as 360 degrees minus theta, or minus our reference angle, which in this case is 30 degrees. Okay? Because it's 360 minus theta, and so that gets you 360 degrees and 330 degrees. Alright? So that's for the domain from 0 to 360 degrees. So this is the basic process of how to really do these questions. Your first step is to find the reference angle by just like solving for this angle x in here. And once you've got that, you then need to identify what quadrants it exists in by observing whether this is positive or negative. And then you adjust for the domain and you work accordingly. So the next example we've got, so the next question is to solve tan theta is negative 1 for 0 to theta to 360, okay? So our first step is, yet again, finding the reference angle. And that's equal to inverse tan of 1. Now it's a positive 1, not negative 1. It's a very common mistake for students to make, to put a negative 1 in here, okay? And if you do end up doing that, you will get an invalid answer using this process. So whatever we're putting in here always has to be positive, okay? So this happens to be equal to 45 degrees. We let the marker know that that's our reference angle, okay? And now this is where the negative comes in. So likewise with the previous example, where we said that it was greater than 0, because there's an imaginary plus here. Because we said it was greater than 0, therefore it lies in the first and fourth quadrant, we're going to use a similar reasoning here. So what we observe is that tan theta is less than 0, or it's negative, which means that it lies in the second and fourth quadrant by the ASTC rule. So it is in the second and fourth quadrant. Okay. So just remembering, it's A, S, T, C. So all of them are positive in the first, sines in the second, tan, and then cos. So where is tan negative? And that's going to be the second and fourth quadrant. Okay? So therefore, theta is equal to, so how do we define angles in the first quadrant with respect to the reference angle? It's 180 minus theta. So it's 180 degrees minus 45 degrees. And then how do we define angles in the fourth quadrant? 360 degrees minus theta, which in this case is 45 degrees. And by just doing this, right, 180 minus 45, that gets us 135 degrees. And 360 minus 45, that gets us 315 degrees. Alright, so that essentially is our solutions for this in the domain from 0 to 360. So the third example we're going to be looking at is this one here, solving tan x is equal to root 3. Now, it's for the previous domains we've been seeing are from 0 to 360. Now, in this case, it's from negative 180 to positive 180. So we're dealing with the negative quadrants here. The process doesn't change. So first things first, we got to find our reference angle. So it's equal to the inverse tan of root 3. Okay? And that's equal to 60 degrees. Let the marker know that's our reference angle. And then we make a statement, but tan x is greater than 0, so it is in the, so where is tan x positive? And that's in the first and the third quadrant by the ASTC rule. First and third quadrant. Therefore, now it exists in the first and third quadrant. So ordinarily, if this was from 0 to 360, we'd have our theta and our 180 plus theta for the first and third quadrant respectively. But we deal with negative angles here. So instead what I'm going to do is just do a basic axis. So we're dealing with the first two quadrants here, that's from 0 to positive 180 degrees. And the negative 2, and then the third and fourth quadrant are dealt with from going from 0 to negative 180. Alright? So how are we going to define these like negative angles here? Because we know it lies in the third quadrant. Okay? So the question is, in terms of theta, how are we defining it going backwards? And essentially, it's minus 180 degrees plus theta. Okay? So therefore, x is equal to, so for the first quadrant, it's simply going to be 60 degrees. And then for the third quadrant, it's going to be minus 180 degrees plus theta, which is plus 60. So minus 180 degrees plus 60 degrees, which is equal to 60 degrees, negative 120 degrees. And if you want to be neat and kind of order them, it's going to be negative 120, 60 degrees. Okay. An alternative method, if you were struggling to understand how this is minus 180 plus theta, solve it normally as you would from 0 to 360. Okay, so this is, maybe I'll indicate here, alternative. So an alternative method that we can use is, well, we know it's in the first and third quadrant. Okay, and we should know how they're defined in their most basic form. So 60 degrees for the first quadrant, and in the third quadrant, remember, it's 180 plus theta. Okay, so 180 degrees plus theta, which is 60 degrees. That's equal to 60 degrees to 40 degrees. Now, what we have is one of these angles does not lie in our domain. All right. So what we've got to do is adjust it to make it fit in this domain. And a way we do that is we can just subtract 360 degrees. Because what you should notice is that, let's say we're at this angle here. Each equivalent angle to this is just 360 degrees, going around and around and around, and in the reverse direction as well. Okay, so I can keep going around by 360 degrees and I'll land in the same spot. So I'll essentially have the same angle. Okay, so what I'm going to do here to adjust it in my domain, because this is way bigger than domain, I'm going to subtract it by 360 to see if it eventually does fall in the domain. So it's 60 degrees, 240 degrees minus 360, okay, and that's equal to 60 degrees minus 120 degrees as we got up here as well, okay. So that's an alternative way to do it, okay. So the final example we look at is this one here, which says solve 2 sine squared x minus 1 equals 0, and it's going to be for this domain. So the first thing that we need to do is basically what you should have noticed is that for the previous questions, it was always the function equals something, okay, and it was just kind of the function by itself. In this case here, we've got a lot of stuff interfering with it, okay. So what we're going to do is kind of add the 1 to get 2 sine squared x equals 1, divide by 2 to get sine squared x equals a half, and because it's sine squared, we don't want this sine squared, we just want sine x, okay. So how we get rid of this squared is we square root, okay. So what we get is sine x equals, now the square root of a half is 1 on root 2, alright. However, because we square root it, it can be plus or minus. So it can be positive or negative, okay? So then we do like the same process. We regurgitate the same process as we've previously done. So we find the reference angle, which is going to be inverse sine of 1 on root 2. Positive 1 on root 2, because remember, we always take the positive. Despite there being a positive and a negative, we just take the positive. And that's going to be equal to 45 degrees. Let the marker know that that is our reference angle, okay. And then we're going to make our little statement, but sine x exists in all 4 quadrants. Now why is this? Now the reason behind this is because we have plus or minus. So sine x is positive in 2 of the quadrants, namely the first and second quadrant, and it's negative in the other 2 quadrants, namely the third and fourth. So that really just covers all the 4 quadrants, okay? So sine x exists in all 4 quadrants. So therefore, x is equal to, so in the first quadrant, it'll just be theta, so 45 degrees. In the second quadrant, 180 minus theta, so 180 minus 45. In the third quadrant, it's 180 plus, so it's going to be 180 degrees plus 45 degrees. And in the fourth and final quadrant, it's going to be 360 minus theta, so 360 degrees minus 45 degrees. Okay, and just by solving these, it's going to be 45 degrees. That's going to be 135 degrees, 225, and 315. So that's basically it. Okay, so there are some 4 basic examples in how to solve trig equations. You really want to, get full marks in these kind of basic questions because the process should be quite self-explanatory, and they're not. Hopefully, they're not too difficult to actually understand. So in the next lesson, I'll be looking at how to actually change the domain. So instead of being, so in all these examples, we were seeing, like tan of 1x, all right? So we had a single x, but what if I was to change this to tan 2x equals root 3, okay? So we'll see in next lesson how to actually solve something like that, all right? And I'll leave you guys with that. So I hope you enjoyed, hope you learned something, and yeah, enjoy your day.